Welcome to this explainer. Imagine for a second that you're standing right in the middle of a high-stakes, fast-paced newsroom. The clock is absolutely ticking down, the pressure is mounting, and a massive, complex story just broke. Now, your editor doesn't just want a messy, jumbled pile of random facts thrown on their desk. No, they want a clear, perfectly structured, hard-hitting headline. Well, guess what? That is exactly what sitting in the Cambridge 9702 physics exam room feels like. Today, we're bringing that intense, highly focused newsroom energy straight to your exam strategy. We are going to break down the syllabus step by step, and our major headline today, quantum physics. Specifically, we're zeroing in on that deceptively simple little formula, E equals hf. We're going to completely transform your approach right here, right now, moving you away from just simple panicked memorization and shifting you into an absolute examiner-approved methodology. I'm going to show you exactly how to deconstruct the toughest questions, surgically extract the right data, and deliver the precise answer that those Cambridge examiners are desperately looking for. Here is our highly organized playbook for today's session. First up, the quantum exam challenge. Then, we move into the method mark strategy. Third, we map out the procedural framework. Fourth, we'll tackle the top 3 examiner warnings. And finally, we will wrap it all up with the physics success blueprint.
All right, let's jump straight into section 1, the quantum exam challenge. And really, this is all about deadline pressure. So let's look at 2 totally typical students trying to handle a quantum physics question using the E equals hf formula. Let's call them Alex and Sam. Now, Alex is what I like to call a data dumper. Alex overloads on raw physics facts. The second they see a quantum physics question, they literally just write down every single equation they have ever memorized. There's zero analysis, just a wall of formulas. Sam, on the other hand, Sam panics the second they hear that ticking clock. Sam rushes the reading phase and completely misses the command word requirements in the prompt. Both of these approaches, they are bleeding marks. Bleeding them. So it begs the question, why do students who genuinely possess the raw physics facts still fail to secure those top marks during multi-stage analysis questions? I mean, if you know that E equals hf, shouldn't that just be enough to get by? Well, the reality is, possessing the raw facts is kind of like having a giant pile of bricks in a field and calling it a house. It's not a house until you actually build it, right? When candidates face a multi-stage problem, they stumble hard because they lack a systematic reasoning process. They either act like Alex, dumping raw facts, hoping something sticks, or they act like Sam, totally ignoring whether the command word was calculate, show, or evaluate.
Let's briefly ground ourselves in the core physics concept here before we pivot immediately back into the exam strategy. What is a photon? A photon is a quantum of electromagnetic energy. It's a discrete, indivisible packet of energy. And mathematically, we define it by the equation E equals hf. E represents the energy of that photon, h is Planck's constant, and f is the frequency of the electromagnetic wave. Now listen closely, because this is crucial. Mere knowledge of this definition is totally, completely insufficient for Cambridge A-level success. Knowing this formula is literally just the absolute bare minimum baseline. It's the ticket into the room. What the examiners actually want to see is how you handle this exact definition when it's buried deep inside a really complex, real-world analytical scenario.
Actually, this quote, pulled directly from the Cambridge Principal Examiner reports, illustrates exactly what I mean. They state, candidates consistently confuse key terminology. Always define terms before using them in extended responses. Look, this isn't a rumor. This is critical, undeniable evidence from the actual people who hold the red pens and grade your papers. The assessment framework heavily prioritizes analytical depth over superficial breadth. The examiners are explicitly telling us right here that poor methodology, not a lack of factual knowledge, is what is actively costing you your target grades. If you just throw E equals hf onto the exam page without first defining what a quantum of energy is, specifically in the context of the question they gave you, you are just leaving easy marks on the table.
Okay, let's dive into section 2, the method mark strategy. This is where we learn how structuring your answers becomes your absolute ultimate safety net.
You need to understand that in Cambridge physics, and specifically within the 9702 syllabus, marks are heavily awarded for your process. We call these your method marks. Honestly, if you make a silly calculator error on the very final step, but your logical reasoning is clearly laid out line by line, you can still capture the vast majority of the points. We're looking at a comparison here, the overloaded raw facts approach versus a context-specific structured analysis. Let's imagine a scenario. You have to explain how the photoelectric effect provides evidence for the particulate nature of light using E equals hf. Alex's flawed answer usually looks like a messy, run-on paragraph. They'll write something like E equals hf, light is a photon, photons hit electrons, work function is energy, so light is a particle. It's chaotic. It lacks any formal structure. Now consider the highly rated context-specific response that utilizes the Peel framework. That's point, evidence, explanation, link. Let's break it down. Point. Light energy is quantized into discrete packets called photons. Evidence. The energy of a single photon is given by E equals hf. Explanation. A single electron absorbs a single photon. If E is less than the work function, no emission occurs, absolutely regardless of the wave's intensity. Link. Therefore, this instantaneous one-to-one interaction proves the particulate nature of electromagnetic radiation. Do you see the difference? That second response earns every single available method mark because it is structured, it is logical, and it is hyper-specific to the context of the prompt.
Now, before we continue and completely break down the exact minute-by-minute timeline of a perfect exam answer, I need you to do something for me. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Seriously, click that subscribe button and hit the bell icon right now so you don't miss a single one of our high-stakes strategy sessions. Right, let's move into Section 3, the procedural framework. This is the systematic, step-by-step methodology you need to totally dismantle complex physics problems. Practical application in quantum physics isn't just about magically getting the right number to appear at the bottom of the page. It's really about developing professional-level analytical skills. You absolutely need a systematic step-by-step methodology to separate the panic of the exam room from actual high-tier performance. So here is that standardized progression. These are the 5 definitive steps to unlocking those higher-grade boundaries. Step 1. Deconstruct the question. What exactly is the command word? Are they asking you to state, to calculate, or to evaluate? Step 2. Extract the data. Pull the raw numbers and units out of the dense texts and tables. Note down things like a nanometer to meter conversion immediately. Step 3. Select your analytical framework. Are you using the Peel paragraph structure we just talked about, or does this require a specific algebraic manipulation? Step 4. Execute your notation. Show you're working clearly, line by logical line. And finally, Step 5. Present terminology. Ensure you are using the exact, precise physics vocabulary that the examiners demand. Let's actually map that framework onto a chronological timeline, because time management is everything. Imagine answering a really high-mark quantum physics question under severe deadline pressure, using our deconstruct, solve, evaluate model. I want you to literally visualize a 5-minute countdown timer sitting on your desk. At 0 minutes, identify the given information, scan the complex physics chart, grab the core trend, and identify the command word. At minute 1, break the problem down into logical steps. Ask yourself, which formulas connect the data I have to the final headline they want? By minute 3, solve systematically. This is where you execute your clear notation, put pen to paper, and calculate. At minute 4, check for reasonableness. Stop and look at your answer. Does your photon energy calculation actually result in a realistic number, or did you accidentally forget that Planck's constant is to the power of -34? Catch those silly mistakes. And finally, at minute 5, justify and evaluate. Present your findings, wrap it up with proper formal terminology. Sticking to the strict pacing ensures you capture every single method mark available without running out of time. Okay, stop scrolling. Look right here. I need to speak directly to you for a second. We have helped thousands of students improve by 2 to 3 full grade boundaries using exactly these techniques. Join them right now. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Turn on all notifications so you never, ever miss our weekly exam strategy sessions. Make the commitment to your target grade right now. Let's get it done. Moving on to Section 4, Top 3 Examiner Warnings. Now, what's really interesting here is that we are pulling focus to the specific traps identified by the actual graders. Think of the principal examiner reports as essentially a cheat sheet of exactly what not to do. We've run them all, and we have distilled them down to the 3 most massive pitfalls when it comes to E equals HF. Let's punch through these rapidly. Warning number 1, using the wrong approach for the wrong context. Students so often try to apply classical wave theory explanations to a question that explicitly, undeniably requires a quantum particulate explanation. You have to know which lane you're in. Warning number 2, forgetting to check format in presentation. This means skipping proper headings, using sloppy terminology, poor formatting, and messy annotations. Let me be clear, if you drop your units, you drop your marks. It's that simple. Warning number 3, Answers are not specific to the context given. This is a huge one. This is writing a generic, memorized textbook definition of a photon when the question specifically asked how the photon concept explains the threshold frequency of a particular zinc plate. You absolutely must tailor your memorized facts to the exact scenario on the paper.
All right, I want to make this a bit interactive. Start a mental 30-second timer in your head right now. I want you to cross-reference this strict examiner convention table with your own recent past paper attempts. Spot the flaw in your own style. When you face the wrong approach warning, your required action is to evaluate alternatives before you even start writing. Did you pause and think, wait, is this a wave question or a particle question? When you risk a format failure, your strict action is to use proper headings, double-check your units, and use crystal-clear annotations. And when you suffer from a lack of context, your required action is to define the exact terms within the highly specific scenario they provided. So find the flaw in your usual answering style right now. Be honest with yourself. Are you an Alex, just overloading facts without any context? Or are you a Sam, rushing the clock and failing the format? Identify your weakness today and apply the required action tomorrow. And that brings us to Section 5, the Physics Success Blueprint. Let's synthesize all this knowledge into your final actionable checklist for exam mastery.
Let's recap this core answering system. First, apply systematic analysis using our deconstruct, solve, evaluate model. Don't just dive in blindly. Second, decode required formats by paying absolute strict attention to the command words. State, evaluate, calculate, they all mean different things. Third, utilize a memory hack acronym to instantly recall our answering framework. For quantum questions, I want you to remember the acronym PHOTON. Let's spell it out. P stands for present the equation. H is for hunt for data. O is for outline your logical steps. T is for terminology check. O means output your final answer. And N is for notation and format check. Photon. Every single time you see E equals HF on a paper, I want you to mentally run through that specific checklist. And finally, present with exact terminology. Always define your terms clearly and in context.
100. That is the number you need to intensely focus on. By adhering to the academic benchmarks of logical, structured reasoning, by strictly applying the PEL framework for written answers, and using the PHOTON memory hack for calculations, you can achieve 100% of your mark potential. You are not going to leave a single point on that table because of a careless formatting error or a panicked, rushed misreading of a command word. Why? Because you are finally playing the game exactly by their rules.
The absolute most crucial point here is this. What we are talking about isn't just theory. We have the social proof to back it up. Students who consistently practice this evaluation and analysis methodology drastically improve their actual results. If you implement these specific physics strategies, focusing heavily on process and those golden method marks, you can see an average improvement of 2 full grade boundaries. Let that sink in. That is literally the difference between sitting at a C and walking away with an A. That is the true power of a systematic newsroom-style approach over sheer blind memorization.
So here is your final reminder. Please do not let another exam pass you by where you lose marks on concepts you actually genuinely understand just because your methodology was off. Subscribe to our YouTube channel, Ace the Exams, at acexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acexams_IGCSE and click that bell. We are here to guide you through every single syllabus point with this exact level of strategic, high-level breakdown.
Before we wrap up, I want to leave you with a provocative question, and I want you to engage with us right down in the comments. What is your target grade for physics, and what is the single biggest challenge you are facing right now? Is it those nasty multi-stage calculations? Is it the really tight deadlines? Drop a comment below with your answer. Our team reads and responds to every single comment because we want to tailor our next masterclass to exactly what you need to succeed. So please, like this explainer, share it with your study partners so you can both practice the PHOTON framework together and keep each other accountable. And make sure you return for our next deep dive. Ace the Exams, your Cambridge success starts here.